Okay, so the last concept that we're going to look at in chapter 3 is the concept of a slope of a line, which should be a review from Algebra 1. But we also want to start to focus in on how it relates to geometry, and in particular, the concept of parallel lines that we've studied in this chapter. And also the concept of perpendicular lines as well. When we have perpendicular lines, it's an extremely important concept to us because they form right angles. So when I think of slope of a line, I always think about a rate of change. So if I'm looking at this line P, let's focus on that for a moment. I want to start at this point -2, -2, and I'm going to move to the point 1, 2. So one of the things that I always like to think about when I'm talking about slope is always read your graphs from left to right, just like you would read a book. You read on the pages from left to right. So this other line, Q, we'll talk about that line as well, and I'm always going to move from left to right. So we will use this formula. We'll be plugging into it, but I really want you to have a visual idea of what we mean by slope, because it's a rate of change. And when you think about concepts that relate to things around us, a rate of change is probably one that's as relatable as anything. Particularly right now, we're in a place where we could think of a rate of growth of or spread of a virus, right? And in terms of slope, it's what we call a linear change, right? Is one thing moves a certain amount, then the other moves the same amount. But the rate of growth of this virus that we're looking at is not linear at all. So what I mean by that is this: like a linear rate would mean that each day there's 2 new cases of coronavirus, right? So on day 1 you have 2, and then on day 2 you'd have 4, and then on day 3 you'd have 6. Really, really simple, and we can see how it's growing. Well, the spread of the coronavirus is probably a little bit more like something that looks like this, not a straight line. It's not moving at a constant rate whatsoever. It's moving much faster. And one example I could think of would be a bike ramp or a skateboard ramp, right? You could build a ramp that is just a straight line that goes like that, okay? But what you see a lot of times for high level skateboards and bikes are ramps that look something like this, because when they're curved like that and the rate of change is constantly changing, you can generate more speed and you can do a lot more with that kind of rate of change. So this line P, as I move from the point at -2, -2 to 1, 2, what happens? I want to talk about a rate of change. So the top number is always going to be how much do I move up or down. So this is how I decide whether or not the slope is positive or negative. So for me to move left to right from this point, -2, 2 to 1, 2, I have to go up 1, 2, 3, 4 units. And then I have to go over 1, 2, 3 units. So we would say that that has a slope of 4/3. And you can see how we get that in our formula over here on the left-hand side. We take the change in y, we take the 2 y coordinates, they take -2 minus 2 and subtract them. And they put that number in the top. Well, I just did it visually by counting. That's a distance of 4. Kind of like when we did the distance formula, finding out how far we're moving. And then in the bottom, they took the 2x coordinates, -2 minus 1, and that's where they come up with, really, they skipped a step here. This would be -4 over -3, but that translates to 4/3. So when I look at it on the graph, I can see it has a positive slope because I have to go up 4 and down 3. Now, the other line that we have over here that I've tried to highlight in red, what happens as I move left to right there? I'm going to start at this point -3, 2, and I want to go to 2, 0. So how do I do that? I have to go down 2. So that is where I'm going to put a negative sign. If I go down, I put a negative sign. If I go up, it's positive. I don't really, when I'm looking at the graph, I don't ever associate a negative sign with the bottom number because I read my graph left to right. It's always going to be a positive number. So if the line goes down and to the right, it has a negative slope. If it goes up and to the right, it has a positive slope. I think that keeps the concept of slope simpler for us. So now I'm going to go from this point, 1, 2, 3, 4, 5, over. And you can see if we plug into the slope formula, it would tell us to take the y coordinate 2 minus 0 in the top, right? And we get 2. And in the bottom, we have -3 minus 2, which would be -5. And then that gives us a slope of -2/5. So you have it both in the formula and also a visual representation. I want to make sure that we're okay with both of them. And finally, the last 2 things that are important to think about here would be a slope of a line that looks like this. This is x and y. What if I have a vertical line that there is no change in x at all? The x value stays the same constantly. This slope, if the line is vertical, is considered undefined. And I like to use a skiing illustration. That would be a cliff. And if you ski off the cliff, it's not really a slope. They don't offer those kinds of slopes. It would not be good for you to ski off of a cliff. So if the line is vertical, it has no slope. And the equation of that would just be x equals a constant. That's where the two y numbers are going to be the same. And then the other special case we have is what happens when a line has a horizontal slope. Right? Well, you can ski on that. That's called cross-country skiing. It's actually a really good workout. So what we say in this case is that the slope equals 0. There's a difference. Okay. Slope of 0 means that there is a slope. You can move along that, but it's going to take. You're not going to get any speed, positive or negative, from the slope. You're going to have to do all the work yourself. Vertical line, slope is undefined. Okay, so we'll keep our eyes open for those situations. And you remember, in algebra, when you divide by 0, if you have a situation where you are dividing by 0, this is undefined. That's an undefined situation. So if we get a 0 in the denominator, that's going to be undefined. If we get a 0 in the numerator, that is going to be okay. All right, that's just going to be a slope of 0. So let's work through a couple of these and then answer a few in the Edpuzzle. Okay. So the first one, we're going to use the slope formula. Okay. We use the abbreviation M oftentimes for slope. So slope, or M, equals the change in y. We're going to take our two y coordinates, and it really doesn't matter what order you subtract them in. If you like to keep yourself organized, I always just take the first one I see, and that's my first number, and I do it for both of them. I'll show you what I mean by that. So in this first problem here, a lot of times you'll see people say, well, this is my y2. They'll label them and say x1, y1, x2, y2. If that's helpful to you, definitely use that method. I like to take the first y coordinate that I see, which is 0, and the other one, and I just do 0 minus 8. We get the same answer either way. I'll show you what I mean. And then I take the first x coordinate that I see. That's going to have to go on the bottom, and that's going to be 0 minus, be careful, negative 2, right? Now, you could have said 8 minus 0 over negative 2 minus 0. We could do it in that order as well. I promise we'll get the same answer. What do I get here? I get a negative 8 in the top and a positive 2 in the bottom. So that's going to be a slope of negative 4. What happens here? We get 8 in the top over negative 2, and that is also a slope of negative 4. So you'll see as I go through these, what I like to do is just subtract them right in the order that I see them. But if you want to look at one of them as the first x and the second and subtract them in that order, that's fine as well. To me, the most important thing is to be picturing slope as a rate of change as we move along the graph from left to right. Okay? Let's try the next one. We want the slope here, so I'm going to take in order negative 5. Oops, I'll go in order instead of doing it that way. Negative 3 is the first y coordinate I see, minus negative 5. This is where I think I'm going to see most of the errors in a couple of regards. First of all, the positive and the negative signs, okay, missing one of those, but also doing it in a different order. Like if I put negative 3 minus negative 5 in the top, then I have to say negative 2 minus 3 in the bottom. I can't, do it one way in the top and then switch it in the bottom. So you have to be very, very careful. And here we have some pre-algebra, negative 3 plus 5, right, over negative 5, okay? So that's going to be 2 over negative 5, or just negative 2/5. You can put that negative sign anywhere you want. In other words, just as a footnote here, we could say 2 over negative 5. That's fine. You could say negative 2 over 5. That's fine. Or you can decide to throw that negative sign out in front of the whole fraction, and that is okay as well. Okay. So let's try to answer some of these in the Edpuzzle as we work through. Slope of this next one here, I'm going to take negative 2 minus 3. Those are my two y coordinates. And then I'm going to take 1 minus negative 6. So I have negative 5, and then this would be 1 plus 6. This would be a slope of negative 5/7. Okay. In the next one, 2 minus 6. We subtract those two y coordinates in the top. In the bottom, we have negative 1 minus negative 9. Okay? So 2 minus 6 is negative 4. Negative 1 plus 9. Be careful with that. Okay? So I have negative 4 over positive 8. This would be negative 1/2. Okay, in number 5, slope is going to be negative 2 minus negative 2. Right? The two negative 2s. We have the same y-coordinate both times. And then in the bottom, we're going to have 1 minus 6. So what happens? Negative 2 minus negative 2, they're just going to cancel out. That's 0 over negative 5. So we said before, that's okay. We can have a 0 living in the numerator. We just can't have it in the denominator. That would be a situation where it's a vertical line and it's undefined. Okay. And then the last one here. Okay, so we take our two y's, 10 minus negative 3, and we're going to divide that by negative 2 minus negative 4. So that's really 10 plus 3, and this is really negative 2 plus 4. So we have 13 over 2.